This is the starter for today's lesson, so I would like you to pause the video and have a go at finding the area of these shapes. Okay, so I'll now give you the answers and you can mark. You should make sure that you've got units for your answers. Remember, with a triangle, we mustn't forget to halve it. And the last one, remember, it's the two lengths at right angles that we need to multiply together. That gives us 6 centimetres squared. Okay, so in today's lesson, we're going to be looking at surface area of a cuboid and triangular prisms. Oh, let's put a G in there, triangular prisms. So you can put that title into your exercise books and today's date. So first of all, what do we mean by surface area? Can you please write this definition of surface area in your exercise books? The surface area is the total area of each face of a 3D object. So how do we find the surface area? Well, we find the area of each face and add them together. So again, if you've printed the note sheet, you'll find this on your note sheet. If you haven't, can you write what's in the red box into your exercise books, please? So if you've printed the note sheet, you should be copying these examples onto your note sheet. If you haven't, then ideally you can do a quick sketch of the diagram and write the example straight into your book. So for a cube has 6 faces. And obviously because it's a cube, all the faces are the same size. So we just need to find the area of one face. So one face is a 3 by 3 square, so that's 9 centimetres squared. And because there are 6 faces the same, we just multiply 9 centimetres squared by 6, and we get a total surface area of 54 centimetres squared. Again, because we're talking about an area, our units are centimetres squared. So let's think about a cuboid now. If you want to, you could find something in your house that is the shape of a cuboid and actually have a look at it. You'll find that for a cuboid, it's made up of 6 faces, which are all rectangles, and opposite faces are the same size. So the top and bottom face will be the same size rectangle, the front and back face will be the same size rectangle, and the two sides will be the same size rectangle. So let's just go through how we find the area and add them up. So if we look at this cuboid here, if we look at the front face, we can see that one, I'm just going to change to blue. So we put our workings is 2 meters by 8 meters. So that face is 16 meters squared. But because we know the back face is the same, I'm going to double it, which gives me 32. So I've got 32 meters squared for the front and the back. The top face we should be able to see. So along here, I know that that's also going to be 8 meters. So my top face is 8 meters here by 5 meters here. So it's 8 times by 5, which is 40. But again, the bottom is the same. So I've got 2 rectangles of size 40. So that gives me 80. And if I look at the sides, I can see the sides are 2 by 5. So I've got 2 times by 5, which is 10. And again, the opposite side is the same, so that makes 20. And then to get the total surface area, I can add those up and I get 132. And this time it's meters, so meters squared. Now it's very, very important when you're doing surface area that you have all of your workings. You must show all your workings for each face and show that you've added them up. Okay, so I'm actually going to put a little plus symbol here to show that I've added those up. Okay, it can be a little bit fiddly, and if you're going to get full method marks, if you do make a little mistake with one of your multiplications, your addition, you must show full workings. Right, what I'm going to show you now is how to get the surface area of a prism. This one's a triangular prism, and we know that it's a prism because the front face is a triangle and the back face is a triangle of the same size. So if I took a slice through the middle of this prism, anywhere along its length of 10 centimeters, I would get the same size triangle, and that's what makes it a prism. But again, we need to work out the area of each of the faces separately and add them up. So I've tried to describe them here so that you can see what I'm doing. And let's see about outlining them as well. So right sloping face, so that's what I'm talking about. This face here, in fact, I might just try and shade it in. This face here, which is a rectangle, okay? And you should be able to see that that rectangle is 10 centimeters by 13 centimeters. Okay, so it's 10 times 13, which is 130. Now, a prism's different to a cuboid. You're not going to have all opposite faces the same size, so I can't just double it. I've just got to work my way around the cuboid. So just going to rub out that red there and pick a different colour. So now I'm going to look at the face on the left side. So this is a vertical standing face, and this is also a rectangle. So let me have a go at shading that one in. So I'm talking about this face here, and that's 5 centimeters that way, and along this edge here, that's got to be the same as this edge here, so that's 10 centimeters. So that rectangle is 5 times 10. So that's 50 centimeters squared. Okay, let's just rub out that green there then. I'm going to pick another colour, so let's pick blue. So now we're doing the bottom rectangle. No, we don't want the rubber, we want the blue pen. So the bottom rectangle is the face that actually sits on the table. So that's this one, another rectangle, and we can see that that's 12 along here and 10 along here. So that's 12 by 10, which is 120 centimeters squared. Oops, let's rub out the shading on that face. So which face are we up to now? Now we're going to have the front face. So that's now a triangle. That's this face here. So remember, with our rectangles, we didn't halve it, but now we've got to a triangle, we have to halve it. So I've got my 5 times 12, which are at right angles to each other, and it's a triangle, so I need to halve it. So that gives me 60 divided by 2, which is 30. Now in a prism, you will find that the front and back face are the same. So now my back triangle is the same. So we could just write down 30 again, but to show full method, I'm going to show how I've worked it out. There I've got another face of 30 centimeters squared. Now to get my total surface area, I need to add all of those up. And if we add them up, so let's put a plus there so I can see I'm adding them, I get 360 centimeter squared. So that's my full method clearly laid out, showing how I've worked out the area of each face and the fact I've added them up to get the total surface area. So in actual fact, can you pause the video now and can you write this example into your books? Let's pop a little emoji there. So either on the note sheet or have a go at a quick sketch and copy it into your exercise books. And then you're going to have a practice at some questions. Now, the questions are all detailed in assignments, but I will put them up here as well and just talk you through them. So you can start today on the challenge, the super challenge, or the hyper challenge. So that actually should have a little comma in there. You can start on the challenge, the super, or the hyper, and I don't mind you using a calculator today. So the challenge is just surface area of cuboids, and you will find the challenge, the tables are laid out very much like the example we just did. If you finish that and you don't feel you are ready to go on to prisms, that's fine. You can do more practice on cuboids from the MyMaths textbook. And don't forget, the answers to the MyMaths textbook I did email you out, but you will also find them on files on Teams for marking. If you want to start on the super challenge, you can go straight to surface area of triangular prisms, and you'll find that sheet attached. if you want to dive straight into the hyper challenge, it's some domino cards. Okay, so if you can print them, you print them out, cut them out along the bold lines only, so they're dominoes. So each card should have two sides to it, so a shape and a question. You should get 12 cards in total. The cards are numbered, so you must show full workings in your exercise book by writing the number of the card that you're working on and showing the method. And you should find that you can make a domino chain with the dominoes that you can stick in your exercise book. If you want to try the dominoes, you don't have a printer, that's fine. You can just write out the order of the cards by their card number in your exercise book. If you start on the hyper challenge and you finish the dominoes, there's some problem solving questions in the MyMaths textbook on page 33 that I want you to go to. Again, they will need to be marked from the MyMaths answers. Good luck, and I'll be available on Teams to help with any questions.